So good day, my people. We have shown our face again today as usual. Now, this is just an explanation on a question that was sent to me because I actually taught them the topic. I was in class with them and I taught them chemical bonding. So while I was explaining, I gave them one of this as assignment. So they were not able to do it. I still gave them extra one, but then they were able to do it after that. So, but then there's this question. Mr. Muiz, please, can you explain the chemical bonding in CO2? CO2 is a compound and it is also a gas. That's carbon dioxide or carbon 4 oxide. Now, to explain the chemical bonding, you must count the number of elements that are found in this compound. How many elements? We just have two elements there. So the first element is carbon and the second is oxygen. But how many oxygen do we have there? We have a total of two oxygens there. Now, since we are having two atoms of oxygen in this molecule of a compound, so what do? To count the total here, we have 1, 2, 3. That's three different atoms. Yes. Now, you see this one, which is only one, that is what you are going to make your central atom. So you call it carbon. Good. After doing that, the next thing to do here is to find out how many electrons does the atom of carbon has. It has 6 electrons because it is on the 6th position in the periodic table. So that means that we have hydrogen, helium, lithium, beryllium, boron, carbon. That's 6. So it has 6. So to configure it using the shell notation, we have the first two to enter the first shell, the first two electrons to enter the first shell. Don't forget, the center of an atom will be there, which is the nucleus, and the remaining 4 out of 6, remaining 4 will be spread all over it. So this is what we call carbon here. Now, how about oxygen? Oxygen is the 16th element in the periodic table. So if you are not sure, let's count it together: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. No, sorry, the 8th element. I beg your pardon. The 8th element in the periodic table. So I'm just looking at the, what's it called? The molar mass of oxygen. That was why I said 16. So if you want to remember the atomic mass of any element, just remember the position that it falls. So according to what I counted now, oxygen falls on position 8. Now, if oxygen falls on position 8, it means that the two oxygen that we have, they are going to have 8 electrons each. Don't forget that we are having 2 atoms of oxygen there. Now, to configure this, what do? We say the first shell will contain 2 electrons. Every first shell, K shell, will contain 2 electrons because that's the maximum number of electrons it can contain. So we have 2 here. Out of 8, how many is remaining? It remains 6. So you can see 1, 2, 3, 4, 5, 6. Anyhow you wish to distribute it. And the other one, we have 1, 2, 3, 4, 5, and then 6. Anyhow that you wish to distribute it. Now, since you have something like this, what do we think is the next one? Now, the essence of chemical bonding is for all those elements that don't have the octet structure to complete octet structure. Now, what is this octet structure? Octet. The word octet means 8. Oct means 8. Now, every element want to attain this octet configuration. Why is it like that? This is because of the fact that every element wants to look like the noble gases. What are the noble gases? We have the helium, we have the neon, we have argon. If you check those ones, their outermost electron, which are the electrons that are found inside their outermost shell, they are 8 except helium that has just 2. So every element, and any element that is what? That is having this octet structure, it means that it is stable. Reactively, it is stable, which means that it will not undergo any type of reaction except some special reactions. I must tell you that. Now, after knowing this, we must know that other elements that don't have 8 electrons in their outermost shell, it means that they want to look like those ones that are having 8. You know, now when you have a rich man in your area, you'll be like, I like the way this man dress. Oh, this man, he has money, I want to be like him. So you know that is your role model. So all the noble gases that are having the octet configuration, they are like, what's it called to them? They are like those ones that they want to look like too. So that is what we have for this. Now every of these elements now, they want to have two electrons in the outermost shell. So according to this now, sorry, eight electrons. According to this configuration now, we have 2 and 4, right? 2 here, 4 outside. We have 2 and 6 here. Can you see it? We have 2 and 6 here. 2 and 6 there. Now these ones, they want to look like the noble gases, which means that they want to have eight electrons in the outermost shell. So it is chemical bonding that will explain it to us. How do we do this? This is how we are going to do it. You know, this is carbon, right? As your central atom is having this. Now this one is having 6 electrons in its outermost shell. This one is also having 6 electrons in the outermost shell. Now there are different types of chemical bonding, and one of the types of chemical bonding is what we call covalent bonding. Covalent bonding involves the sharing of electron in between the what? In between the bonding atoms. Those atoms that are bonding, they are going to share their electrons. I'll bring mine, you bring yours. So let's see how this is done. This is covalent bonding. Now we are going to use the covalent bonding to explain this. So this is having 4, this is having 6. Now if this one brings 2 from here and add to this one, what do you think is going to happen? It means, don't forget that I told you that covalent is about sharing. So the internal consists of 2 electrons, and this one consists of 6 before. So 1, 2, 3, 4. Then the remaining 2 to complete 6, just put it here. 5, 6. Don't forget that this one is from carbon. So this one, I'm shifting it here. So if you check the number of electrons on this oxygen alone, you see that it is 8. Yeah, let's count. 1, 2, 3, 4, 5, 6, 7, 8. It has attained the octet configuration. How about the carbon that is in the middle? Has it attained? We have 1, 2, 3, 4, 5, 6. It is 6. It remains 2. Now you now see this one also. We bring its shell closer so that it can share with carbon here too. Don't forget the middle one. The first shell contains 2. Now the 6th one will be 1, 2, just like this. 3, 4. It remains 2, 5, 6. Now if you check the number of electron that is in the outermost shell of this oxygen too, you see that it is 8. Let's count. 1, 2, 3, 4, 5, 6, 7. I think it is the remaining one. Yes, that's one that I removed from that place. That's 8. You can see that this is what? 8. Count the one in the middle to 1, 2, 3, 4, 5, 6, 7, 8. Yes, okay, this one I removed it and put it here already. So this is also 2 and 8. Why this one to 1, 2, 3, 4, 5, 6, 7, 8. This is 2, 8. Now in this kind of reaction, you will see that what all of them, they are having 8 electronic configuration, and this is what we call the octet configuration, and this is the reason why all of them are reacting. So if they ask you any question about why elements in the periodic table wants to react, it is because they want to look like the noble gases. And what are the noble gases? The elements in the periodic table that are having the octet configuration, and that is all. You can see that this question is as simple as that. So to my student that actually sent me this question, I know that it is tough, but then it is simple when you do it quiet and easily. So thank you for watching this video. It is nice meeting you again.